Yeah, I'm not collecting these, but I tell you, if you did your quiz, actually did the problems and you did well, and the quizzes were very good, and the work was there, that's great. And I messed up. I really, really did mess up. These are supposed to be negatives, that's gonna. My apology. That's supposed to be a negative 12, or else it's not like the actual questions that you have to do in quiz. That makes them really kind of useless right here. But these are the same types of questions that you had on your quiz, taken up just a little bit, instead of just a nice number like a 72 or 49 or whatever that was. It's now a radical. And so you had a couple of radicals and simplified. The quizzes all the time are really good as a take home. But then everything falls apart when I'm grading tests on this test. And I scratch my head, and as you can see, I don't have a whole lot left to scratch. I know I'm not as bright as I look. Wait, let's just say I'm not that bright. I can't even understand that comment. I'm just not that bright. There's ways to get around actually when it's take home, not doing the stuff yourself. But that's not why you're here. That's absolutely not why you're here. It's like, you know, can you call it cheating? If you're copying somebody else's, then probably. If you're applying technology, well, then that's just me applying technology. That's what it's there for. We're just capitalizing on the fruits of everybody else's labor that came before us. I use a calculator. And before that, we used somebody else's slide rule. Before that, we used the monks' tables that put them in the back of the book from the monasteries of the 1500s. They made tables of everything, so we didn't have to go do it ourselves. But you can understand the process. And take your tests, and you don't have notes, and you don't have that access to an AI, or you have to show all the steps yourself. On a test in the past, these are just like, I get gibberish. So I'm giving you these examples. These are off of old tests that I will be using to make your new tests. Old Testament, New Testament. And it's just the same 4 problems that you did on your quiz. And you start with the order of operations. It's an addition problem, and you got to simplify it before you can actually add these together. But the first parentheses, 7 is a getaway car. I'll bring down that 7. Let's see what breaks out of that square root 98. Give me 2 numbers that make 98.
7 and 14.
7 and 14, not a bad choice. I would never have thought of 7 and 14. Not a bad choice. So now you got a 7, and you got a 7 times a 2. So you have a 7 that escapes, and a 2 that goes back in square root jail. So, and you have to be neat about this, and that's, I was really impressed with how neat most of the quizzes were. Much better than I'd seen in a long time. So a 7 will escape, and then you have that square root 2 back in that jail cell. And again, when you do a problem like this, it's one tiny piece at a time. leave that alone and move on to the next one. Before you run out of that, what did I just do on this? If you keep going, you'll forget to do the rest. Then it's a -4. So don't forget, it's a -4 times whatever escapes out of this.
6 and 8.
Well, the first thing you do is you poke out the eye. Square the negative, because there should have been a negative when I first wrote it. So you're gonna poke out the eye, and we said 6 and an 8. 6 and an 8. And then they have 3 and a 2. And remember, 8 is always 2 times a 2 times a 2. 3 2s, 2 to the third. So now you're gonna have a 2 escape, and you're gonna have another 2 escape. So you're gonna have a 2 times a 2 escape and a 3 back in square root jail. So what actually escaped? A 4 square root 3 left in jail. So the 4 escaped and the square root 3 back in jail. One thing I did notice about quizzes, when you did do that, simplify the square root, I saw them going over here on the sides. And that's fine, but then you got to bring that stuff way over there back over here. And you got to make sure you bring down the getaway card and make sure that's there. And you got to make sure you put it in the right spot. You got to make sure you remember to multiply this out. So just be careful. That's why I try to work from left to right and put the next piece right underneath where it came from. Now, since this is addition, we're not going to have to distribute a negative. The signs won't change. So if we drop the parentheses right now, that would be okay because it's addition. Plus this positive is going to stay positive. Plus that negative is just going to be a negative. But when it's subtraction, you got to be really careful. If you just want to play it safe, you're supposed to do what's in the parentheses before you do the addition. I'm just going to play it safe. Plus, I'm going to keep the parentheses. We have a getaway card that's a 5. So 5 is waiting to see what's going to break out of square root 50. Now, again, I keep telling you, over here, this is the one that doesn't have a square root of the negative. So if anything's going to combine with this 5 square root 50, it's going to have to be the one that doesn't have a negative. This one ends up with a square root 2. So if I'm going to combine this one with something, it's going to have to combine with a square root 2. So I'm hoping there's a square root 2 in here. Give me 2 numbers that make the 50. 5 and 10. And you have a 5 and a 5 and a 2. So a 5 will escape. And a square root 2 left behind. That's good news. Got a square 2 there. And then we have -6, next getaway card, times poke out the eye. Well, if I'm going to combine that square root 6 square root negative 12 with something, it's going to have to combine with this imaginary square root 3. So I'm hoping to get a square root 3 out of this. And 12 is what times what? What?
134.
Say again? Give me 2 numbers?
Oh, 3 and 4.
3 and 4. Okay, 3 and 4. So 3 times 4. And the 4, you get 2 and a 2 and a 3. So a 2 escapes. And you got square root 3 right there. And if you know that it is, 2 square root 3 because you've done square root 12 before, I don't mind if you just go straight to 2 square root 3. This is 2 square root 3. What I don't want to see is that you go from -6 times square root -12, you go straight to -12, because this is going to be -12i, and go straight to this being -12i without showing that you simplified this first. You got to show this before you show the next step. So one tiny piece at a time. Now we're gonna finish up what's in here. Gotta do our multiplication before we can add and subtract. So this 7 times 7 square root 2 is 49 square root 2. Minus 4 times 4i square root 3 is negative 16i square root 3. Plus 5 times 5 square root 2, that's a plus 25 square root of 2. And it's plus this, and then it's going to be plus a negative minus 12i square root 3. And then we combine the like terms. First of all, the ones that don't have I are the real components, the real parts. And I have 49 of these square root 2 plus 25 of those square root 2s. So 49 plus 25 is going to be 74 of those square root 2s. And then I have negative 16 of these I square root 3s and another negative 12 of those I square root 3s. So negative 16 of them and another negative 12 of them is a negative 28 of those I square root 3. And there's only maybe a little less than a handful of this, which I don't want. The I should go in front of a radical if there's a radical involved in the number. Because I did see some that put it behind, and I saw it looking like that. And now it looks like I is inside the square root because it's just messy. And if that happens, points get taken off. As far as you can go. That's the plan. Question 2 of the quiz. This was just a nice number. That was just a nice number. Or let's put it this way. It was like a 9 square root 25. So that becomes a 9 times a 5. So this becomes a nice 45. 9 times square root 25, 9 times. This becomes a nice 45 instead of that doesn't simplify. So what do we do here? One piece at a time. We distribute. But I recommend you don't try to multiply in your head. Write it out. If you can multiply in your head, I don't mind. But you gotta, want to see this. If you don't see what I'm about to do, then you're gonna want to write down the step that I'll go back and show you. This first term times that first term is going to be 27 times a 5. 9 square root 5 times 3 square root 5 is 27 times 5. If you don't see what happened when I just did that, here's what you should do. Write this down. 9 square root 5 times that 3 square root 5. That's what happened when I distributed. So the way that's multiplied together, the 9 square root 5 times the 3 square root 5, we can rearrange them so I can switch the order. Let me just actually do it this way, every little tiny little details. So this is drop the parentheses, 9 square root 5 times square root 5 times the 3 times the square root 5. And then I can switch the order of the square root 5 and the 3. That's the commutative property of multiplication. So now I have 9 times the 3, and then times the square root 5 times the square root 5. There's my 27. Square root 5 times square root 5. When you multiply a square root of a number times itself, there's two things you can have happen. The first thing is I am squaring the square root of 5. Square root of 5 squared. So square root 5 squared is just 5 because I square the square root, it undoes the square root. Anytime you multiply square root times itself, it undoes the square root. If it, it has to be the same number though. Square root 3 times square root 3 is just the 3. Or the square root of an A times the square root of a B, you can multiply the inside to get the square root of A times B. So this would be the square root of 5 times 5. That's the square root of 25. And what's the square root of 25?
5.
It's just 5. Because these are the same square roots, the radicands are the same. Then you're going to get a perfect square inside the square root. So when I take the square root of that 5 squared, I get 5. So anytime I multiply a square root times itself, I square it. It just undoes the square root. So that's why I can go from 9 squared 5 times 3 squared 5. I can go straight to 9 times 3, which is 27. And square root 5 times square root 5 will be a 5. 9 times 3 is the 27. Square root 5 times square root 5 will be the 5. But if you're not seeing it, then write this first. This one times that one. Already screwed up. I got ahead of myself. I was so eager to show you the whole multiply that 9 squared 5 and 3 squared 5 because of the square root 5 squared 5. What did I not do first? Nobody stopped me. It was your fault. I didn't simplify what's inside first. I didn't simplify the other stuff. You gotta do what's in the parentheses. I can reach in the order of operations and I didn't do it. I should be sitting in the corner. You ever see I know this is way, way, way before your time. Back in the old, way before my time, where they would make a kid put on that little phone hat and dunce hat and sit in the corner. Okay. Would get something wrong. It was all about shaming way back when. Yeah, and so. So we'll come back to that part. Maybe we need to put teachers in a dunce hat. I don't know. We'll put a new one. All right, so that's not going to change. That's simplified. Minus, poke out the I. What's the square root of 100? So that's a 10i. So 9 squared root of 5 minus 10i. And again, this is what it will look like on your test. I'm telling you right now, this is the same question, different number. That's 3 squared root of 5. That's simplified. And that's a plus. Poke out the I. What's the square root of 81? So that's a 9. There we go. That's better. I need to edit that from the video. All right, now this one was, I'm gonna get the 9 square root 5 times that 3 square root 5. So I'm gonna take it one step at a time. So it's that. And then before I do this next distribution, signs, get your signs right. Be really careful with the sign. Positive times a positive is gonna be a positive. Don't write it small, make sure it stands out because you mess up the sign, things are gonna go sideways. And write it out. This is 9 squared root 5 times that 9i. And then we have a negative times a positive. So the next sign is going to be a negative. And we have that 10i times the 3 squared root 5. And last times last, a negative times a positive, that's gonna be a negative. And on the quiz, there's not a lot, but there's again, less than a handful. The sign has to be there, and you have to write this step in. 10i times 10i, you don't have to write it as 10i times 10i, but you need to at least write down 90 and the I squared. You can't go straight to, all right, that's gonna be a 90 I squared is -1. -1 times that's gonna be a positive, so that's gonna be positive. You can't go straight to positive 90. Even though you may know that it's gonna end up being positive 90, on your test, it's gonna be a negative. And you gotta show that 10 times 9 is 90, and then I times I is gonna be I squared. But I'm gonna go ahead and write it down. This is 10i times 9. And you can see it happen. So we do this part. 9 times 3, there's my 27. I'm in a hurry. There's only 14 problems on this, 6 bonus questions. You don't have to hurry. The next one, plus. Again, careful on the signs. 9 times 9 is 81. Square root 5 and an I. So we're going to put the I in between the 81 and the square root 5. 81, I, and then your square root 5. You want that minus? 10 times 3 is 30. We have an I and a square root of 5. So again, I is between 30 and the square root of 5. And then we have a minus. 10 times 9 is 90. And you have an I squared. You have to, you gotta show me the I squared. You can go from here to here. You don't have to show that step between. And I'm showing it because I want, some people are gonna say, well, where did that step here from? 27 times 5 is 135. These two are like terms. I don't have a real number yet. That one still has I squared. I have 81, positive 81 of these I squared 5s. And then I'm going to take away 30 of these I squared 5s. They're the same kind of term. So it's 81 of them, take away 30 of them. Positive 51 of those I square root 5s. Those are done. And then over here, we have a negative 90. I squared is a negative 1. So this ends up being a plus 90. So the last thing I have to do, these two real numbers, the 135 and the 90 is 225 plus 51I square root 5. This time, I'm going to simplify what's inside. So parentheses, 1 minus 5, what's this? Put square root negative 1. 2i. Now we're going to square that. So this is 1 minus 5 times 2i, that's 10i. And then we're going to square it. I'm just gonna go ahead and show the distribution, 1 minus 10i times itself, 1 minus 10i. You just don't square each one. If you want to use the special product rule, go ahead. I'm just gonna write it out. 1 times 1. Positive 1 times negative 10i, so that's a negative 10i. A negative 10i times 1 is another negative 10i. And here's what I saw on, again, less than a handful. The last sign, a negative times a negative, is a positive. I was getting straight away negatives there. Because they anticipate the I squared being a negative, so they went ahead and made this negative. And then they had the I squared, which means if you have a negative in an I squared, it ends up being positive, so the signs are all messed up. Negative times a negative is going to be a positive. 10i times 10i is 100 I to the second. So there's my 1, negative 10i, minus 10i, that's negative 20i. And that's going to be plus 100 times negative 1, so minus 100. 1 take away 100, negative 99 minus 20i. That's one fraction. You can't have I in the denominator. So when you have two terms like that, you got to multiply by the conjugate. What is the conjugate of 1 plus 2i? 1 minus 2. Now, I know I wrote this on quite a few. If I'm going to multiply the denominator by 1 minus 2i, I got to multiply the numerator by 1 minus 2i. And you can't multiply these together unless you have parentheses. So I put on many quizzes needs parentheses. If you don't have parentheses, you're not actually going to multiply it all out. If I just have 1 plus 2i, and then I can have parentheses on this, but this means all I'm multiplying is the 2i with this one, not the 1. I'm not multiplying the whole thing times it. You did, but what you have here does not give this. It's not mathematically grammatically correct. Mathematically. So these parentheses are going to multiply. And then we distribute again. We have 2 times 1. We got a positive 2 times a negative 2i, so that's a negative 4i. We got a positive I times 1, so that's a positive I. And we have a positive I times a negative 2i. So positive times negative will be negative. I times 2i is 2i squared. Down below, it's the difference of two perfect squares. So I should get 1 squared minus the whole thing, 2i squared. If you don't want to use the difference of two perfect squares, then it's 1 times 1. 1 times negative 2i. Positive 2i times 1. And then positive times a negative will be a negative. 2i times 2i is 4i squared. You're going to get the same answer if you FOIL it out. Why, now we gotta simplify. In the numerator, we have a 2. Now, there's no other real numbers here. Negative 4i plus I. Negative 4 plus 1 is negative 3i. This is negative 2, and then I squared is negative 1. So negative 2 times negative 1, this ends up being plus 2. The negative 2i squared ends up being a plus 2. In the denominator, there's a 1. In the middle, they cancel out because we can't have I down here. Negative 2i plus 2i cancel out, 0.
So the 2i squared. It turned into a positive.
Yeah, because the I squared is a negative 1, so it's negative 2 times that negative 1. And that becomes plus 2. Just like right here, this negative 4 times the I squared, that I squared is a negative 1. So negative 4 times negative 1, that ends up being plus 4. So we just finished adding these together. In the numerator, you got 2 plus 2. Take away a 3i. In the denominator, we have a 5. Here you can stop. On the quiz, it could reduce. So you had to either factor it or split it or simplify it. But here, there's no common factors for 4, 3, and 5. This can't reduce, so you can leave it like this. But if you want to split it, just to make sure it doesn't reduce, you could go 4/5 minus 3i over 5, and that's the same thing. But if it does reduce, you either have to show the factoring or the splits when you reduce it. And I didn't take off points from the quiz, but those that didn't show the work for simplifying it, I said, on the test, it's not going to work. We'll get to show the work. So those are test examples of what you did on your quiz. And I'll point out to the 10 o'clock people that, hey, they can watch this one to see the test examples. You have a quiz, you have the review sheet. If they want to see stuff on the review sheet, they can ask. Right now, it's all on you. What do you want to see? Again, all the review sheets were taken when they gave out the quizzes last Wednesday. So I have no more copies. On review. That's not review sheet. That was the notes. Oh, that was the notes. Review sheet looks like this. Yeah, so review sheet is still, posted on Canvas, emailed it, posted in the announcements. I know there's more than enough printed, but they seem to have disappeared. So on 12, you have to use the quadratic formula to solve this. Solve using the quadratic formula. So 1/4 x squared minus 2 equals negative 7/6 times x. There's the notes of the quadratic formula. Step one, make sure it's in standard form. Undo the fractions. You do not want to plug fractions into the quadratic formula if you can avoid it. Undo the fractions. Now, this thing has fractions. And if I'm going to put it in standard form, I certainly don't want to put it in standard form using the fractions either. So can undo the fractions, multiply every term by the least common denominator.
2.
Now, here's the problem. Again, we seem to be stuck on what is the least common denominator. If I multiply by 2, that is not going to undo 4. I want to undo the 4. I want to undo the 6. 2 goes into 4, yes, but I still have a 1/2. It's not going to undo it. So I would at least need to multiply by 4 to undo the 4. But if I multiply by 4 over here, it's not going to undo the 6. So what's going to undo a 4 and a 6? 24 will work. Is it the smallest number? If I use a bigger number, then I got to put bigger numbers into the quadratic formula, and then I got bigger numbers to crunch. The least common denominator that will undo both of those at the same time. The first number they go into even is 12. So I just over here on the side, write it down. I got a 4 and a 6. 4 goes into 4, it goes into 8, it goes into 12, 16, 20, we got 24. 6 goes into 6, 6 goes to 4. So we're looking at the multiple. Now what goes into that? We're not reducing fractions. We're multiplying by something so we can reduce the fraction. Everybody has to get multiplied by 12. Even the 2, because if you don't multiply every term by the 12, then it's a different question. And remember, when you simplify, right, 4 goes into 12 3 times. I have 3 times 1 times x squared, so that's 3x squared. Minus 12 times 2 is 24. Equals, it's a negative. 6 goes into 12 2 times. I have this 7 times that 2, so that's a 14x. Undo the fractions. Now it's much more manageable. Now we got to put it in standard form. One side has to be equal to 0. Rewrite the equation in standard form. Make one side equal to 0. Undo fractions if necessary by multiplying every term by the least common denominator. So I'm going to make one side 0. That means, and I want to keep x squared. I want to keep it a positive term. It's good, it's positive. So that means I want to bring everybody over here with this positive 3x squared. The only one on the wrong side is this one. How do I bring the negative 14x over to the left side? I have to add it again. I do have to see that you add it to both sides. I got to see the word. So now I have 3x squared, and it should go in the middle because your terms have to go in decreasing degree. So x squared, x is the first, minus 24 equals 0. So that's step 1, just getting it ready to use the quadratic formula. The quadratic formula is basically plugging A, B, and C into an equation to solve for x. A, B, and C are the coefficients. We're solving ax squared plus b times x plus a constant equal to 0. So that's why step 2 is make a list. What is A, what is B, what is C? Don't make a list way over here on the side and go like, okay, A is this, B, don't do this. Go again, right underneath, because that's where the A and the B and the C are. A is what? 3. B is 14, and C is -24. Just for point of reference, when you guys give you crap about the boxes aren't big enough. Let's see. Completing the square, it's basically you have 1/4 of the page, quadratic formula, 1/4 of the page to do all of the problem. Okay. So those should be big enough. Hopefully you have well, you need to have the quadratic formula memorized. But every time I use it, I'm gonna write it down, so I'm just gonna make the substitution that x is equal to the opposite of b, and if you're gonna memorize it as you do the problem, when you're doing homework, when you're doing the review sheet, say it to yourself as you write it out, so you have it ready to go on Monday, the 21st. The opposite of b plus or minus the square root of b squared minus 4 times a times c, the whole thing divided by 2 times the a term. Just, that's the formula. The next step. That's between the square. Then you just plug in, substitute A, B, and C in, and then you simplify. So B is 14, so we get x equals the opposite of B, that's the opposite of 14, plus or minus square root. When you square these things, if it's a negative, you better put it in parentheses. So it ain't gonna hurt if you just put B in parentheses no matter what. So 14 squared minus 4 times A, which is 3, C, which is -24. The whole thing divided by 2 times A, so 2 times 3. Substitute. I know that 2 times 3 is 6, but one step at a time, just substitute. Now we simplify. That's the last thing. -14. Plus or minus. Square root. 14 squared is 196. Get the sign. This is a negative times a positive times a negative. So what is the sign going to be? It's going to be a positive. That gets messed up. Right there, focus on the sign. Negative times a positive is a negative, and then times a negative, so it's going to be a positive here. And then we have 4 times 3 is 12, and then 12 times 24, so that's going to be 288. Okay. All over 6. One ninety. 484. Is that right? All over 6. And 484 squared is 22. Is that right? Yes. That's why I give you that list of perfect squares and powers and things like that. So if you know them, or you can simplify it out or check it on a calculator. First thing, if it was me and I was sitting in your seat, I might punch it in. Maybe it's a perfect square. Please, please, please. And if it is, hey, I don't have to do a factor tree. And square root of 484 is just 22. So x is equal to negative 14 plus or minus, that is exactly 22 over 6. You have to simplify completely, which means if you can keep going, you have to keep going. If this was x equals negative 14 plus or minus 22 I, if it was imaginary over 6, the only thing we could do would be, we have a common factor of 2, we would have to reduce by 2. Let's say it was a 7, just to be kind. I can't reduce because 7 doesn't go into everybody. So that could stop right there. There's no common factor for 14, 22, and the 7. I could do the splits and reduce the 14 and 7, but I don't have to. I could just leave it like this. I can't combine 14 into 22 I can stop right here. But if I can keep going, I have to keep going. If I can combine stuff. So that means I'm just going to split this into 2 answers. I have one answer, negative 14, and I always do the minus one, minus 22 over 6. And the other one is x equals negative 14 plus 22 over 6. You split it up into plus or minus, negative 14 plus it, negative 14 minus it. Or in my case, like, because I know negative 14 minus the number is going to be the smaller of the two. Negative 14 minus 22, that's negative 36 over 6. So that's negative 6. Negative 14 plus 22, so that's equal to positive 8 over 6. And that is 2 times 4 over 2 times 3. So this is equal to 4 over 3. So at the bottom of the box, x is equal to, I have a negative 6 and a positive 4. Don't do with this branch real quick. Let's say this was a quiz question or test question where it came from this direction, or we'll put it over here. It was under these directions. Solved using any algebraic method. So you don't have to use quadratic form. You don't have to do it. You do it any way you want. Okay. So we start with the whole fraction. And you still are gonna undo the fraction because I don't want to solve it with a fraction. So I'm gonna get it to the 3x squared minus 24 equals negative 14x. And I'll probably still make one side 0, so I'll add the 14x to both sides. Because if I'm headed towards, quadratic formula, then I'll have to have an equilibrium. So I'll still end up here. Now, but you have to use quadratic formula. This kind of question on the test would be bonus. The actual test mandatory quadratic formula is not going to have fraction. Bonus question. Because I know as soon as some of you see the fraction, it's like, I want out. So it's on the bonus. But if that was the question, I would try factor. We don't have a common factor, so I would set up the parentheses. First times first is 3x squared. So the only way to make a 3x squared would be what times what? Three x times x. It has to be a 3x times an x. That's the only way to make a 3x squared. If it factors, that has to be the first two terms. And then the sign. Last times last is a negative number. So the only way we can get a negative is if these two multiply and make a negative. So my two signs have to be
Plus and minus.
plus and minus. They have to be different. So this one's positive, that one's negative. I might have to switch them. We'll see. And then last times last is 24. Well, there's lots of ways to make it 24. So I'm just going to make a list real quick. It's not that hard to make a list of 24. It might be 1 and 24. It could be a 2 and a 12. It could be a 3 and an 8. It could be a 4 and a 6. It could be a 6 and a 4. So I got 64. So now it's guess and check. You want to try 2 and 12? If I try 2 and 12, the only way it's going to fit, it would be a waste of time to put 12 with the 3. Because if I put 12 and 3 together, this parentheses has a common factor of 3. I can take a 3 out of both of these. And if I can take a 3 right now, I should have been able to take a 3 out of the whole thing. So there's no point in putting 12 with this 3. The only way it's going to factor with the 2 and the 12 is if I put the 2 here and there's 12 there. That's the only way. Check the middle. We want 14x in the middle. 3 times negative 12x, 3x times negative 12, that's negative 36x. 2x, I'm saying the answer without saying the question. 2 times x with positive 2x. The only way these puzzle pieces will fit is going to give me negative 34. I don't want negative 34. So if I try 2 and 12 in the puzzle, the only way it works is not going to work. So that means it's not 2 and 12. So let's try it over. 3 and 8. Can't put 3 with 3. Okay, because 3 and 3 would have a common factor. So it has to be an 8 here, 3 there. So we check the middle, check the OI. Outside times outside, plus inside times inside. So 3x times negative 3, that's negative 9x. 8 times x is positive 8x, that gives me negative 1x. Nope. So it's not 3 and 8. So we have 2 choices left. Or 6. Who is a waste of time here, the 4 or the 6? The 6 and the 3 should not be in the same parentheses. So if it works, it has to be a 4, has to be a 6. Outside times outside is negative 18x. 3x times negative 6. 4 times x is positive 4x. That makes negative 14x in the middle. Perfect. Maybe, maybe not, but look, I want positive 14x. I got 14x, but we're almost there. You have the right amount, wrong sign. You never switch the number. When you have the correct amount, all you do is switch the sign. To get the positive instead of the negative, you switch the sign. So we're going to make this one the negative and that one the positive. And that'll change the sign of what we just did. You switch the sign. The right amount, wrong sign, switch the sign. Because now 3x times 6, that is positive 18x. Negative 4 times x, that's now negative 4x. 18 minus 4 is 14. There's my factor. So since it factored, 3x minus 4 equals 0, x plus 6 equals 0. You let each factor equal 0. Add 4. 3x equals 4. Divide by 3. This x is 4 over 3. Subtract 6. This x is negative 6. Negative 6 and a 4 over 3. Quadratic formula takes a lot of thinking out of it, but you have to crunch a lot of numbers. It might be bigger. Who knows? Factoring is, there's fewer places to make mistakes as long as you're checking what you're doing. But you got to have confidence in your factoring. You can't just, look at it and say, I'm never going to do factoring. I don't want to do that. You're not going to get through your math classes unless you are willing to do factoring. Trust me when I tell you, but the trick classes are dealing with this right now. And to factor that. So instead of x's and y's, they're using sine squares and cosine squares. So if they can't factor x squared and y squared, they're going to struggle with sine squares, cosine squares. Not to mention at some point they have to use substitution and change sine to cosine. This is the part of that where I love it, and I'm just sitting up here giggling, and they're sitting there going, "What happened?" Some of them. Okay. All right. At 10 o'clock, the show is going to be on you. We're going to be doing whatever you want to do. Those of you who came in late, I'll hand back your quizzes, but you need to make sure you check in, so I have you here. Turn off the recording though.